In this video, we'll work on all problems of AMC 10A 2023 and we'll extract background ideas, more than 30 ideas. I leave more than 10 homeworks and I release 4 videos exactly one day before AMC 10A 2023. I covered more than 140 ideas and I left more than 45 homeworks, and we will see many of those problems were useful in this exam AMC 10A 2023 and also AMC 1012A 2023. And you will see they are useful also in AMC 10B, 12B 2023 and AME and USUMO. Also, I will release some important videos in near future. If you want to learn 40-50 important ideas in each topic, combinatorics, algebra, number theory, and geometry, feel free to send message to my WhatsApp number in the description. Okay, let's start. Okay, this problem is first problem of AMC 10A 2023 and 12A 2023. Let's read. So cities A and B are 45 miles apart. Alicia lives in A and Beth lives in B. Alicia bikes towards B. Okay, so let's draw. A is here. B is here. And Alicia bikes towards B at 18 miles per hour. Living at the same time, Beth bikes towards A at 12 miles per hour. Okay. And how many miles from city A will they be when they meet? Okay, because which of them is faster? B. So we will see something at some points like this. In these types of problem, let me tell you, first idea is using this formula. When you have a speed, this formula, by only using this formula, you can solve many problems in AMC 8, AMC 10, and so on. Okay, so here we consider, because it says how many miles from city A will they be when they meet, you consider this one as x. Okay, and this one will be what? 45 minus x. And because they leave at the same time, and when they reach here, their times are equal. Time 1 equal times 2. So t is what? D over v by using this formula. V is the speed, velocity, d distance, t time. d1 over v1. t2 is d2 over v2. Okay, d1 is what? d1 is for example, a. Is x over speed of a is what? 12. d2 is what? Is 45 minus x. v2 speed of b is what? 18. Okay, now we should find x. If we multiply both sides by 6, here it will be 2, here it will be 3. If we cross multiply 3x equals 90 minus 2x, okay, then we take 2x to left hand side, 5x equals 90. Oh, sorry, here. Alicia here is 18. Okay, so let's change this 18 on 12. Okay, 18, 12. If we multiply by 6, it will be 3, it will be 2. If we cross multiply 2x equals 3 times 45, 135, minus 3x. If we take it to the left hand side, 5x equals 135. And if we divide by 5x equals 235, 7. So the answer is choice E. And we have homework from AMC 10 problems related to speed. I should search exact problem is what. If you want to know the homework exactly is what, or want to prepare for next part AMC B, or want to know 40-50 important ideas, feel free to send message to my WhatsApp number. This problem was first problem of AMC 10A 2023 and AMC 12A 2023. Okay, problem 2, second problem of AMC 10A and 12A. It's a common problem. The weight of 1/3 of a large pizza together with 3 1/2 cups of orange slices is the same as the weight of 3/4 of a large pizza together with 1/2 cup of orange slices. A cup of orange slices weighs 1/4 of a pound. What is the weight in pounds of a large pizza? Okay, So we consider pizza as P and orange as O. So if you want to write 1/3 P over 3, or 1/3 of P, plus 3.5 of O is the same as, wait, 3 over 4 times P, plus 1 over 2 times O. Okay, and it says O is what? Is 1 over 4. And we want to find P. Okay. Here we can say 3 over 4 minus 1 over 3, 3.5. You can say 3 times 2, 6, plus 1, 7. So 7 over 2, O equals minus 1 over 2O. Here for P it will be 3 over 4 minus 1/3. 3 over 4 minus 1/3 P. Okay, 7 over 2O minus 1 over 2O is 6 over 2 is 3O. If we use common denominator, 12, 9 minus 4, which will be what? 9 minus 4 is 5. P. Okay? And then we can say what? We know that O is 1 over 4 is 3 over 4. We can multiply both sides by 4 is 3. So P is 9 over 5, which is 1 and 4 over 5. So the answer will be choice A. Okay, if you had any question, feel free to send message to my WhatsApp number if you want to learn other ideas. Okay, AMC 10A 2023 and 12A 2023, problem 3. How many positive perfect squares less than 23 are divisible by 5? So it means what? A perfect square that is divisible by 5, you can write it as 5. For example, k whole squared less than or equal 2023. So 25k squared less than or equal 2023. Now we can divide both sides by 25. So 202 will be 8. And 2 will be left 23, 80 point something. Okay, so k is at most what? 9 times 9, 81. So 8 times 8, 64. Okay, so the answer is choice A, 8, because k can be from 1 because it says positive. Let me tell you idea 2 and also homework 2. Idea 2 is when you want to hear 80 was easy. But if you want to take a square root, it has a strategy. And I said this strategy. For example, when you want to say 2023 from right, you divide digits 2 by 2, then you say 4, 4, 16. Then you say 4, 2, 3. And then you multiply this by 8, by 2, 4 times 2. And here it will be 4. Okay, so it should be greatest one that is less than or equal 4, 2, 3, 4, 4, 16. And we have 1, 4, 8, 32, plus 1, 33. If you place 5, it will be greater. So it is 44 point something. Okay, so if you want to learn completely this idea, because we should work on some problems, you understand this idea better, to taking square roots. It is so much fast. In AMC as homework too. One problem of AMC 2022. And one part of that, when you want to approximate, you should use same thing. Okay, if you want to learn this idea completely, know exact homework is what, or learn 40, 50 important ideas, feel free to send message to my WhatsApp number. AMC 10A 2023, problem 4. A quadrilateral has all integer side lengths, perimeter of 26, and one side of length 4. What is the greatest possible length of one side of this quadrilateral? Okay, let's draw, for example, a general quadrilateral. It is A, it is B, it is C, it is D. So one length is 4. Let me tell you, we have something like triangle inequality. We can call this one as idea 2, idea 3. Okay. Idea 3 is what? Triangle inequality. And we have similar thing for quadrilateral. It means what? Look for triangle inequality. If you see like this one plus this one will be greater than this one, right? Right, for example, side here. And here we can say, okay, for example, AD plus AB for all length, we can say this. DC is less than AD plus AB plus BC. Okay, and it says greatest possible length is what? We know the perimeter is 26 and all of them integer. Okay, for example, let me tell you one thing that we have. If the greatest one is 20, okay, what's the problem? Because 20, we know 4, and if we consider the others, it will be 4 plus, for example, 1 plus 1, something like this, because the perimeter is 26. Okay, so we can conclude what? The side that is greatest one, let's call, for example, that one G. G is less than sum of the other length. It will be 26 minus G. So we can conclude what? 2G is at most 26, strictly. So G is strictly less than 13, so G is less than or equal because it is integer 12. And we can say our side lengths are what? For example, 12, 4, it will be what? As an example, because we want to say it's possible. 12, 4, and the next one is what? We can consider 16, 26, 5, 5. And if you check this inequality for each of them, 12 is less than some of the others, and also for others it will be correct because 4 is less than 12 plus 5 plus 5. Okay, so the answer is D. Okay, so the answer is choice D. Okay, and we had this inequality. Okay. AMC 10A 2023, how many digits are in the base 10 representation of 8 to the 5 times 5 to the 10 times 15 to the 5? The idea here that we want to use, let's write idea 3, idea 4. The only thing you should pay attention, each 2 times 5 will be 10. Okay, also when you want to find last digits, for example, how many zeros do we have at the end of the number, this idea useful, so I can tell you homework 3, we have some problems like this and in AMC or other exams, and we can also use Legendry's formula. Okay, and then you use this idea, idea 5. Legendry's formula is that when we have p is prime and you want to find power of p in n factorial, it will be n over p plus n over p squared and so on. If you want to know the reason or want to learn other ideas, you can send message my WhatsApp number. Okay, let's solve this one. 8 is what? 8 is 2 cubed, so 2 cubed to the 5 times 5 to the 10. 15 is 3 times 5 to the 5. So the first one is 2 to the 15 times 5 to the 10 times 3 to the 5 times 5 to the 5. So it will be 2 to the 15 times 5 to the 15 times 3 to the 5. 3 to the 5, so it will be 3 to the 5 times 10 to the 15. So 3 to the 5, 3 to the 4 is 81. 3 times that is 243. And then how many zeros are there? 15 zeros we have. So 15, 16, 17, 18. So how many digits are there? The answer will be choice E. Okay. AMC 10A 2023, problem 6. An integer is assigned to each vertex of a cube. The value of an edge is defined to be the sum of the values of the two vertices it touches. And the value of a face is defined to be the sum of the values of the 4 edges surrounding it. The value of the cube is defined as the sum of the values of its 6 faces. Suppose the sum of the integers assigned to the vertices 21, what is the value of the cube? Okay, so I told this idea before the exam. If you saw my videos, idea 4, idea 5, idea 6, exactly before the exam, AMC 10A 2023, I said an idea double counting. In which part? In combinatorics part. When you see like this, you should see we calculate each vertices how many times. Okay, so it says what is the value of the cube? Value of the cube is sum of the 6 faces. Okay, now if we consider each face, so let's see how many times do we count this vertex. Suppose it is A. Effect of this A is here, A on these edges. Effect of this A on this face is 2A, on this face 2A, on this face 2A, and on the cube, sum of the faces, 2A plus 2A plus 2A, 6A. Okay, 6A. So we calculate each vertex I've considered from the vertices, okay? Changing viewing angle. And 6A, so sum of the, for each vertex, 6A the coefficient, so sum of the value of the cube is 6 times sum of the vertices, 21. It will be 6, 1, 2, 6. So the answer is this. If you have homework, let me tell you, homework 3, homework 4. In AME, also, in AMC we have similar problems. In AME also we have similar problems. In AMC also we have. If you want to know, in AME it is something like this. Sigma of A intersects B, and it has something, AME 2021, I think. And I should search to find exact problems of what. If you want to know exact homeworks are what, I want to prepare for next exam, like this one that I said double counting before the exam, feel free to send message to my WhatsApp number in the description. I told this idea before the exam. Okay. AMC 10A 2023, problem 7. Janet rolls a standard 6-sided die 4 times and keeps a running total of the numbers she rolls. What is the probability that at some point her running total will equal 3? Okay, for this one, we should use casework before the exam. I released 4 videos and about preparation in each topic: combinatorics, algebra, number theory, and geometry. If you saw that video, I said you should use casework in many problems, and we solved some problem with this idea. Okay. So here, if you want to reach total equal 3, so case 1 in first step 3, case 2 in second step 1, 2, 2, 1. If in third step we reach, it will be 1, 1, 1. Okay. Now I solve it with 2 ways. Solution 1. You say, okay, the probability of this one is 1 over 6, this one 1 over 36, this one 1 over 36, and this one 1 over 216. Okay, and the probability is what? Sum of them. If you use common denominator 216, it will be 6, 36 plus 6 plus 6 plus 1, 42, 48, 49 over 216. Okay. If you want to solve it like counting problems, good cases over bad cases, for the first one, when we see 3, you say, okay, we consider for all of them 3 rows, 1, 2, 2, 1. And for third one, you say, okay, 1, 1, 1. Then you say, okay, here are 36 cases. Here are 6 cases, 6 cases, 1 case. All cases, good cases over all cases. All cases 6 cubed. Good cases 36 plus 6 plus 6 plus 1. Again, it will be 49 over 216. Okay. Now let me see, I told you 4, 5 homeworks. We have homework 6 in AMC 2022. Also, we had a problem related to dice and something like this for probability. That problem also useful. Okay, if you want to know exact problem is what, feel free to send message to my WhatsApp number, or if you want to prepare for AMC 10B, 12B, or AME, use SUMaC. AMC 10A 2023, Barb the baker has developed a new temperature scale for her bakery called the bread scale, which is a linear function of the Fahrenheit scale. So let me tell you, linear means what? Idea 7, idea 8. It means that, for example, when bread is a linear function of Fahrenheit, it is AF plus C, which A and C are constant. Then it says bread rises at 110 degrees Fahrenheit. So for F, we have 110. It says which is 0 degrees on the bread scale. So 0. Bread is baked at 35 degrees Fahrenheit. So this one, which is 100 degrees on the bread scale. Bread is done when its internal temperature is 200 degrees Fahrenheit. And what is in the degree of the bread scale? So x, we want to find x. So from first two equations, if we replace, we will reach two equations, two variables. We will find a and c, so then we will have the function and we can find x. From first one, b is 0. 0 is a 110a plus c. From second one, b is what? B is 100. Okay, equals 350a plus c. And for this one, x is 200. A plus c. We want to find 200a plus c. Okay, so for this part, if we subtract these two things, this minus this 100 equals this one 240a. So a will be 100 over 240. Okay, we will cancel if we divide both numerator and denominator by 2, 5 over 12. And if we replace here in first one, 0 equals 110 times 5 over 12 plus c. We can cancel 2, it will be 6, and this one will be 55. So c will be negative what over 6? 5 times 55, which is 275. And now, if we replace, b is what? B is 5 over 12 f minus 275 over 6. It is our function. Now, we want to find x. X is what? 200 times a, which is 5 over 12, minus 275 over 6. We can cancel 2, it will be 100. Then we use common denominator 6, 500, minus 275, which will be 225 over 6. And if we divide both numerator and denominator by 3, it will be 2, 7, 575 over 2, which is 37.5. Okay, so the answer will be which choice? Choice D. Okay, so if you want to learn other ideas, and we worked on many ideas that were useful in this exam before the exam. If you want to learn for next exam, AMC 10B, 12B, AME, USAMO, feel free to send message to my WhatsApp number in the description. AMC 10A 2023, a digital display shows the current date as an 8-digit integer consisting of a 4-digit year followed by a 2-digit month followed by a 2-digit date within the month. For example, Arbor Day this year is displayed as 2023-04-28. For how many dates in 2023 does each digit appear an even number of times in the 8-digit display for that day? Okay, here we know that when we have 2023 first part, then in these 4 digits we should have at least 1 0 and 1 3. Because number of zeros and 3 should be even. Okay, so let's first consider the month. Okay, number of days in each month. January in 2023. First month 31, second month 28, and so on. Okay. Now we want to focus on number of 0 and number of 3. Okay, so how many zeros? Number of 0, number of 3. 3 1 1 3 or 1 1. Okay, it should be odd. We don't have any other cases. This part is not possible because 3 zeros we have here at most 1 0, here at most 1 0, because 0 0 0 0 we don't have, so this case is impossible. Here we cannot have 33 also here, so similarly this case not possible. Only we should check case 1 1. Okay, so we have 1 0. Let's consider cases. Again, we use casework. Idea casework. I said here it will be, let me check, idea 9. Yes, idea 9. Here we should use casework. And I said before the exam this idea. Okay, let me see. Have we worked on casework? Yes. Before the exam, I told this idea, and also another idea that is important is idea 10. We consider the most limited case, okay? And you will see how we can use it. Also, I told this idea before the exam. Okay. Now we have 1 0 1 3. We consider, for example, place of 0. Okay. So here we can also consider place of 3. Okay, in AMC 12, it is a common problem in AMC 10 and 12. I said we consider 0 here. I want to consider 3. Is 3 possible here? No. So let's consider 3 here. So we can say what? Let's do something. Try to solve. I will solve because if you use case for each part, homework 6, homework 7. Try to work on 3. Okay, instead of 0, and you should reach same answer. If you had questions, send message to my WhatsApp number. Okay, let's consider 0 the first place. Then we will have what? If you place 0 here, then we can have, for example, 1 in this part. And then we have 31, 31, 13. 31 possible because in first month we have 31 days. Okay, 2 cases. If we have 0, 2, second month, it should be 23 because number of 2 should be even also 23 or 32. 32 not possible, only 23 possible, 1 case. If you have 0, 3, we should have same digits here, 1, 1, 2, 2. 2 cases, okay? And if you have 4, then we should have 43 or 34, all of them bad. Now let's consider case 2, 20, 23. If we have 0 here, so we know 3 cannot be here, so 3 is here, okay? 3, if we have 3 here, let's see what are the cases. We have 3 here, 3 here. Let's consider this digit. This digit can be 1. Let's focus on this. Because it is 1, so we have 1, 1, 1, 3, 31. In 10th month, we have 31 days, okay? So 31 and 13 possible. So 2 ways, case 3. 2023. If you have 0 here, then 3 cannot be here. 3 cannot be here because we don't have 0, 3. We have 1, 0. 3 should be here. So here we should place same digits. 1, 1 only possible. So 1 case. And last part, if we have 2023, we have 4 digits. 0 here. So 3 here. 3 cannot be here because we don't have 0. 3 cannot be here. So the only case is this. And again, we have 1, 1, okay? 1, 1. So 1 case, 1 plus 1, 2, 2 plus 2, 4, 4 plus 2, 6, 7, 9, okay? So 9 cases, choice E. If you want to learn other ideas, feel free to send message to my WhatsApp number. AMC 10A 2023, Maureen is keeping track of the mean of her quiz score this semester. If Maureen scores an 11 on the next quiz, her mean will increase by 1. Okay. So here I told you 10 ideas. Idea 11 is what? Is this one, that the average, you should pay attention. You should use this formula. Average equals sum over number of them, for example, n or k. Here it says if Maureen scores on 11 and 11 on the next quiz, her mean will increase by 1. So s over k plus 1. If we have 11 in next quiz, s plus 11 over k plus 1. Next one, if she scores an 11 on each of the next 3 quizzes, s plus 11, 11, 11 over how many quizzes are there? K plus 3, because we have 3 new quizzes. Her mean will increase by 2. Okay. Now we can say it will be s over k plus 2. And then it says what is the mean of her quiz scores currently. So we want to find s over k is what? Okay. We have also other problems related to this idea. How many homeworks? 8 homework, 10. AMC problem, AMC 10 problem related to this idea. I should search. If you want to know exact problem is what, feel free to send message my WhatsApp number. Okay, in the description. We can use common denominator here and here, common denominator. over k. So for first one, if we cross multiply, let me move this part here. S plus 11 times k equals s plus k times k plus 1. So we can multiply sk plus 11k equals sk plus s plus k squared plus k. Okay, so sk will be cancelled. If you subtract k from both sides, it will be 10k equals s plus k squared. Now if you work on this part, it will be s plus 33 over k plus 3. If we use if we use cross multiplication, then s plus 33 times k equals s plus 2k times k plus 3. Okay, so it will be sk plus 33k equals sk plus 3s plus 2k squared plus 6k. Now we can cancel sk from both sides. 33k minus 6k. 27k equals 3s plus 2k squared. Okay, now we've reached two equations. The first one is this one, and the second one is this one. Let's write them on top of each other. I want to find s over k, so I want to get rid of k squared. So I multiply first one by 2, it will be 20k equals 2s plus 2k squared. Now if we subtract this one minus this one, 27k minus 20k, 7k, 3s minus 2ss, and 2k will be cancelled. If we divide both sides by k, 7 equals s over k, so the average is 7. Okay, if you want to learn more ideas like this, want to prepare for AMC SUMaC or other exams, feel free to send message my WhatsApp number. Okay, this problem is question 11 of AMC 10A 2023 and problem 9 of AMC 12A 2023. It says a square of area 2 is inscribed in a square of area 3, creating 4 congruent triangles. Okay, so here is square root of 2 because area is 3 and this length is the square root of 3. This is what is the ratio of the shorter leg to the longer leg in the shaded right triangle. So we can consider this one x because they are congruent. This one will be x. This one will be root 3 minus x. Now we should use Pythagorean theorem. Before the exam I said that. Idea 11, if we consider this one. Okay, because it is common problem, let me write like this, Pythagorean theorem. And also I said before exam double Pythagorean theorem. That was useful in AMC 2022. Here we don't need double Pythagorean theorem. We need only Pythagorean theorem, and I said before the exam that this theorem is useful. Okay, in my videos, exactly one day before the exam. So x squared plus root 3 minus x squared equals root 2 squared. So it will be x squared plus 3 plus x squared minus 2 root 3x equals 2. If we simplify, it will be 2x squared plus minus 2 root 3x, 3 minus 2, 1 equals 0. Now we should use quadratic formula. Again, before exam I said quadratic formula useful, also important properties about quadratic equation. Again, before the exam. Now x is what? Negative 2 root 3 is 2 root 3 plus minus. This one is squared, which is 12 minus 4ac minus 8. Over what? Over 2a, which is 4. So it will be 2 root 3 plus minus 2 over 4. So it will be root 3 plus minus 1 over 2. One of the answer is 4 because x and root 3 minus x in this equation is similar. One of them root 3 plus 1 over 2, one of them root 3 minus 1 over 2. It says what? Shorter leg to the longer leg. So the answer will be shorter leg is root 3 minus 1 over 2 to longer leg root 3 plus 1 over 2. We can cancel these twos. Root 3 minus 1, root 3 plus 1. And now we should rationalize. It will be root 3 minus 1, root 3 minus 1. Denominator will be root 3 squared 3 minus 1. This one will be root 3 minus 1 whole squared, which will be 3 plus 1 minus 2 root 3 over 2, which will be 4 minus 2 root 3 over 2, which will be 2 minus root 3. Okay, so our answer is this, which is choice C. Okay, if you had any question, you can send message to my WhatsApp number in the description if you want to learn 40-50 important ideas and formulas in geometry and other topics. AMC 10A 2023, how many 3-digit positive integers n satisfy the following properties? The number n is divisible by 7. The number formed by reversing the digits of n is divisible by 5. Okay. I said some ideas. Let me check idea. It will be what? Before that, we had idea 11. So we can say idea 12, 13. Idea 14. I said when you want to check for some divisibility by 9, 11, 5 before the exam. I said the rules are what? Exactly the day before the exam, I released 4 videos. You can see them. One part was this. Here, when it says divisible by 5, the last digit should be 0 or 5. Okay, now it says how many to satisfy this property. The number n is divisible by 7. Okay, so the first digit cannot be. When you reverse it, look, for example, it is ABC. It is multiple of 7. Then when you reverse it, it will be CBA. It is multiple of 5. So A is 0, it's not possible because then it is not 3-digit number. A is 5. So when A is 5, this one will be okay. So our number is what is 5BC, and it should be multiple of 7. So we should find 7K that are at least 500 and at most 599. If we divide all 3 sides by 7, it will be 7, 49, 10, 71 point something, less than or equal K, less than or equal 8 times 7, 56, 39, 585 point something. Because K is integer, K is at least 72, but 71 is not greater than or equal 71 point something. At most 85. Okay, 85 is less than or equal this, 86 not. And now the answer will be what? 85 minus 72 plus 1. And it will be 13 plus 1, 14. So the answer will be which choice? The answer will be choice B. Okay, if you want to learn, we have also homeworks. It will be, how many homeworks did we have here? Let me check. Sorry, we solved this problem. I told you 23 problem ideas. So here it will be 23, 24. And homework will be what? One homework we can say. I don't know it is the number of homework. But we have AMC 2021 problem. It says, for example, which number is not prime? One digit is 8. And you should consider mod 11, something like that. You should use same idea, okay? If you want to know exact problem is what, or want to prepare for AMC or other exam, feel free to send message to my WhatsApp number. AMC 10A problem 2023. Abdul and Cheng are standing 48 feet apart in a field, okay? Suppose, for example, A here, B here, this length is 48. Farshid is standing in the same field as far from Abdul as possible so that the angle formed by his lines of sight to Abdul and Cheng measures 60 degrees. Okay, so it will be something like this. For example, this one. But it says because it says we want to select maximum, for example, something like this. But we should check. So we call this one 60. So this is a geometry problem. It says what is the square of the distance in feet between Abdul and Barot? So we call this one B, this one A. We want to find maximum of B squared. Let me copy the choices. Okay, the choices are these. Now for solving this problem, because it says 60, we know if we want to consider all 60s, it will be a circle. One part, and also here we have same thing, but it's not important. Because by symmetry, we want to find maximum B squared, we can only consider top one. Okay, so point C lies on this circle. We want to see for which CB will be maximum, okay? Now, or we can also, if I want to draw the real circle, it will be something like this one. A bit smaller. This, okay. C should be here. And now, the radius of this circle, we have in geometry, I told you, idea 24, idea 25. In geometry, I told you we have 4 important lines. Medians, angle bisectors, perpendicular bisectors. For example, in perpendicular bisectors, R is A over 2 sine A. This part important. Also, before the exam, I said this. You should memorize these formulas, 40, 50 important formulas, especially in geometry. Okay, one of them is this, length of circumradius. So here, if we use, it will be A over 2 sine A. A is what? A is 48. And here it's 2 sine 60. So it's not important that C is in what point of this arc. R is constant. It's 48 over 2 times root 3 over 2. So we can write it like this. We can cancel, or we can rationalize 48 root 3 over 3, which will be 16. 16 root 3. Now, we want to find maximum B. Again, we can say R equals B over 2 sine B. So B equals 2R sine B. And we know sine B is at most 1. If B is 90, then sine B is at most 1, and we have equality. Because we want to find maximum. So it will be 2R. So the equation is possible. Equality holds when B is 90 degree. So it will be 2 times 16 root 3, 32 root 3. And it says maximum square of this is what? So it will be 32 squared times 3. 32 is 2 to the 5, so it is 2 to the 10. When we raise it to the power of 2, it's 1024 times 3, so it will be 3072. Okay, so it was perpendicular related to perpendicular bisector. For example, length of median is what? Altitudes, orthic triangle. In AMI also orthic triangle useful. If you want to learn those 40, 50 important formulas in geometry, feel free to send message to my WhatsApp number in the description. The answer will be choice C. AMC 10A 2023, a number is chosen at random from among at first 100 positive integers, and a positive integer divisor of that number is then chosen at random. What's the probability that the chosen divisor is divisible by 11? Okay. So here again we should use casework, and I said I release a video the day before the exam. Before the exam. If you saw that video, I said casework and we solved some problems. So here we know that if the divisor be multiple of 11, we know that the main number is multiple of 11. It can be 11 or 22 or 33 or 44 or 55, 66. Let's write it 77, 88, 99. Okay. These numbers here, the remainders are 111. The probability that the divisor is multiple of 11 is 1/2. For 22, the remainder divisors are 1, 2, 11, 22. So again, it will be 2 over 4 or 1/2. Always it will be 1/2. Why? Because look, in these problems, we have 11 to the 1 times something. So we have 11 for divisors. We have 11 to the 0, half of them. have 11 to the 0. Half of them have 11 to the 1. So, okay, so 1 half. For this one, again, also 1, 3, 11, 33. Again, it will be 2 over 4 or 1 half. For this one, 1, 2, 4. And then 11, 22, 44. So it will be 3 over 6 or 1 half. This one, this one, this one. This one, 1, 5, 11, 55, 2 over 4, 1 half. This one, 1, 2, 3, 6, and then 11, 22, 33, 66. Again, we have 4 over 8, which is 1 half. For 7, similarly, we have same thing, 1 half, 1 half, 1 half. Okay, so the first number should be multiple of 11. The probability is 9 over 100. We have 9 good numbers, and we want to select from 1 to 100 good cases or all cases. Then the probability for all of them is 1 half, so it will be 9 over 200. So the correct choice is what? The correct choice is this. Also, let me tell you, it was homework. What homework? For previous one also, we can have homework. Similar problems, homework. Okay, so let me tell you. Homework. In AMC 2022, we had a probability problem related to casework. Also, in other AMC, not only AMC 2022. AMC, it was 2019 or some year, I should check. In many problems of AMC, we have probabilities and you should use casework for those problems. And one problem was related to Ramsey's theorem. Okay, it is a I remember it was a pentagon, and for example, you color each edge with black and white, and it says the probability that there is, for example, triangle that all sides are reds or blues. So in that problem, also you should use casework, and you can solve like exactly this one. So as you can see, the background ideas are same. If you want to learn important background ideas, feel free to send message to my WhatsApp number. AMC 10A 2023 problem 15, an even number of circles are nested starting with a radius 1, so this one radius 1, increasing by 1 each time, so this one is 2, this one radius is 3, 4, 5, 6, for example, 7 and 8. All sharing a common point, this common point. The region between every other circle is shaded, starting with the region inside the circle of radius 2, but outside radius 1, it will be this part. Okay. An example showing 8 circles is displayed below. What is the least number of circles needed to make the total shaded area at least 2023 pi? Okay. We know, let's consider this part. This part is what? Pi or times 2 squared minus 1 squared. Why? Because area of the circle is pi r squared. Plus pi next one, this one is 4 squared minus 3 squared. 4 squared minus 3 squared. Plus pi, this one, 6 squared minus 5 squared. Last one, so it says we have even number of circles, so it will be pi times 2k squared minus 2k minus 1 whole squared. Now we want to solve this one. Okay, we factor from pi, it will be 2 squared minus 1 squared plus 4 squared minus 3 squared plus 6 squared minus 5 squared. It is similar to another problem in AMC 12 or AMC 11 of this year. Here again you can solve it with two ways. Let's use the identity a squared minus this identity. I told you for general and a minus b, a plus b. So here it will be what? Pi 2 minus 1 is 1, 2 plus 1 is 3. 4 squared, 4 minus 3, 1, 4 plus 3, 7. 6 minus 5, 1, 6 plus 5, 11. And as you can see, the common difference is 4. 2k minus 2k minus 1, 1. 2k plus 2k minus 1 is 4k minus 1. Okay. Now, we know that sum of elements of an arithmetic sequence is first one plus last one times number of them is 4 times 1 minus 1, so times k over 2. It should be at least 23 pi. We can divide both sides by k. 4k minus 1 plus 3, 4k plus 2. 4k plus 2 over 2, 2k plus 1. So 2k plus 1 times k is greater than or equal to 2023. One way is to check choices, another way, again, you should use the idea I told you before. Here it's idea 25, idea 26. For N also, I said before the exam, the day before the exam, I released a video, 4 videos. In one of them, I said exactly this one. And the other one, I want to use a strategy for taking square root. It has an algorithm. Use it here if you want to know exact. Without this algorithm, also you can solve, but because it is a small number. But if you have large number, I told you an algorithm. If you want to know exactly is what, feel free to send message to my WhatsApp number in the description. So if I want to find this, it is around what? This one is around 2k squared, around 2023. So k squared should be around 10, 11, 10, 12, let's say, or 10, 11. We know what. Okay, we know that k is around, it's a bit greater if you say 32, okay? And we can also say 31 for example. Okay, and we can check. If k is 31, then 31 times 2 times 31, 62 plus 1, 63. We want to see this work. So 31 times 63, 63, 9, 18. So with this 3, 5, 15, 9, this. It is smaller, so it doesn't work. K32, it will be 32 times 2 times 32 plus 1, 65. So if you multiply this by 65, 32 times 65, 2 times 65, 130, 3, 5, 15, we have 1, 18, 9. So it will be 8, 0 to 280. And it is greater than equal 2023. It satisfies, so K32. How many circles are there? 2K. So 2 times 32, 64. So the answer is this one. So if you want to learn how to work with these, for example, identities, how to apply identities, it is a simple one. Feel free to send message to my WhatsApp number in the description. Another homework is one problem of this year. I don't remember it was for AMC 10 or 12, we have same thing. And also, we have some other things related to series. If you want to learn them again, you can send message to my WhatsApp number. Okay, this problem is AMC 10A, problem 16, and AMC 12A, 2023, problem 13. It says in a table tennis tournament, every participant plays every other participant exactly once, although there were twice as many right-handed players as left-handed players. The number of games won by left-handed players was 40% more than the number of games won by right-handed players. There were no ties and no ambidextrous players. And what is the total number of games played? Okay. So here, suppose it says number of there were twice as many right-handed. Okay, so as left-handed. So R equals 2L. And we can say what? We can say, okay, it is R, which is 2L. It is L. Number of games equals what? And N is R plus L. Okay, number of players. What is the total number of games played? It will be N choose 2. Okay, because each 2 player plays exactly once. Here the problem says. N is R plus L. We want to find N choose 2. So let's calculate each choice. And we know R is 2L, so 2L plus L, 3L. For choice A, if it is equal to N choose 2, N choose 2 is N times N minus 1 over 2. So for choice A, N times N minus 1 over 2 is 15. So N times N minus 1 is 30. And N is integer. So positive integer. N is what? N is 6. Okay, for first one, N is 6. For choice B. And we cannot reject this because 6 is multiple of 3. For choice B, N times N minus 1 over 2 is 36. So it is a necessary condition, not sufficient. n times n, we want to see we can reject which choices. N times n minus 172, 9 times 872, so n is 9. Let's check choice C. N times n minus 1 over 2 is 45. And let me tell you, number of games played in this part, in graph, we can call it idea 19, idea 20, 21, 22. Okay, these parts. In graphs, we have this idea. In tournament, we have n choose 2 games. So this one is n times n minus 1 equals 90. So n equals 10. But this one doesn't work because n should be 3l. So we could reject choice C. For choice D, n times n minus 1 over 2 is 48. So n times n minus 1 is 96. It's not possible because if you consider, for example, 10, let me check. For 96, for example, if we check 15 or 11, 11 times 12, or let's check here. 11 times 12, or let's write 12 times 11 over 2 is what? Is 66. Okay, so it is greater. 11 times 10 over 2 is 45. So this one is 45. Next one, two consecutive triangular numbers. Here we call these numbers triangular numbers. 48 is between these two consecutive triangular numbers, which we can conclude there is no n. So we can reject choice D now. Last one, 66. Okay. For choice E, 66, n times n minus 1 over 2 is 66. So by considering this, we can consider n equals 12. Okay, so here n equals 12. And here n equals 9. Here n equals 6. Something, sorry. Let's say 12. No, that's okay. Now let's see which one is possible. It says number of games won by left players was 40% more than the number of games won by right-handed players. Okay, so W, let's see, won by left-handed was 40%. Okay, WL is 1 plus 40% times WR. Okay, and we know WL plus WR equals W number of games. For example, look, when we have 3 things, if we consider winnings of all players, we calculate each game once from the winning part, from the winner. So W equals n choose 2. And we can say, okay, it is 1.4 WR. So if we replace WL is 1.4 WR plus WR, it will be 2.4 WR. It will be what? It will be 24 over 10 WR. So n choose 2 is 12 over 5 WR. If we multiply both sides by 5, 5 times n choose 2 equals 12 WR. So we can conclude 12 divides 5 times n choose 2, and by Euclid's lemma, I told Euclid's lemma before the exam, idea 22, idea 23. Euclid's lemma. I told this one before the exam. It's an obvious lemma. If A divides BC and GCD of A and B is 1, then A divides C. Okay. So 12 and 5 are relatively prime, so by Euclid's lemma you can say 12 divides n choose 2. Now we want to see which choice is multiple of 12. Not A, not E. So the answer is 36. Okay. Now let me tell you example for this 36. For this one, n is 9. Okay, so because n is 9, L will be what? L will be 3 because it's real. Here 6. We have 6 right-handed, 3 left-handed. Let's try it like this. And 3 left-handed. And here we consider, okay, it's like this one. It is not important between them. It is what, but we consider all edges between them from this part to this part. When we consider this one, A wins B. Okay. Now I want to say this example works. How? Here we know, for example, this one is right-handed equals 6, left-handed equals 3, WL equals 1, 2, 3, 3 edges here, plus 3 times 6, 18, 21. WR is what? 6 choose 2, because each game here has one winner. Is 6 choose 2, which is 15. And now I want to say 21 is 1 plus 40% times 15. Let's see, is it correct or not? 1.4 times 15, which is 14 over 10 times 15. We can cancel 2 by here, 7, and 5 by here, 3, 21. We will see it's correct, okay? We wanted to check this, and this example works, okay? You don't need to find this example. If it was for example, use some full solution exam, you have to find an example. Maybe also we have some other answers except 36, but if you consider the choices, 36 only possible. Okay, if you had question or wanted to learn more things, like this one, important ideas in number theory, Euclid's lemma, and many multiplicative inverse, many important ideas, 40, 50 important ideas in each topic, feel free to send message to my WhatsApp number in the description. AMC 10A 2023, problem 17. Let ABCD be a rectangle with AB 30 and BC 28. Okay, so it will be something like this. If I want to show, for example, 30, and let's consider, for example, 31.5, and this one 1.4. So it will be something like this. And this one is A, because AB is 30, so we can call this one AB, this one C, this one D. It says P and Q. P on BC, Q on CD, respectively, such that what? APB, ABP, this triangle, PCQ, this triangle, and QDA, this triangle, have integer length. What is the perimeter of this vortex? Okay, what's the perimeter of APQ? Okay, so here we can consider this AB is we can use assumption. From assumption is 30. This one is 28. Let's consider this one as A, this one as B, this one as C, this one as D, this one as E, F, G. Okay. Now let's work on these two triangles that we know one side length. 30 squared equals A squared plus 30 squared plus, by using Pythagorean theorem, plus A squared equals E squared. Now we use 30 squared equals A squared minus A squared, E squared minus A squared. One idea, Pythagorean theorem. I said before, exam useful. One idea using AN minus BN factorization in general. Okay. Now here we can say it is E minus A times E plus A. Now 30, because E minus A and E plus A, both of them were odd or even. Both of them odd or both of them even. So, because this part is even, odd times odd will be odd. Contradiction, so both of them should be even. Now we can say what? Because both of them are even, if we check the cases, it is 2 times something, it is 2 times something. 30 squared is what? Is 2 squared, this 2 squared because of these 2's, and then 15 squared. 15 squared is what? Is 3 times. 3 times 5 times 4. Okay, now we should consider the smaller one should be here. So if we consider, for example, here 3 here, it will be 3 times 5 times 5. We have problem. Why? Because when you subtract e plus a, for example, e plus a is 2 times, let me contradict one case, and then we can contradict other case quickly. 2 times 3. Then when we subtract, subtract 2a equals 2 times 3 times 5 times 5 minus 3. And we cancel 2. So 3 times 5 times 5, this one. 75 minus 3, 72. Is it possible? No, because a is at most 28. Okay, so their difference should be at most 28. So 3 not possible. Also, if you say 5, 3 times 3 times 5, it will be 45, 5, 40. A will be 40, but a should be at most 25, 28. So if you consider 15, 15, it's not good for a smaller one. 9. 925 only works. Okay, so we can conclude e minus a is 2 times 9. E plus a is 2 times 25. If we subtract 2a will be 2 times 25 minus 9. So if you divide by 2, a will be 16. Okay, so this one will be 16 and this one will be 14. Now, because it's 30, it is 16. E will be what? E minus a is 18. So E is a plus 18, which is 16 plus 18, which is 34. Okay, so E will be 34. Now let's focus on this triangle. 28 squared plus d squared equals g squared. 28 squared plus g squared equals d squared. And, plus d squared equals g squared. So again, we do the same thing. 28 squared equals g squared minus d squared, g minus d, g plus d. Again, g minus d and g plus d, both of them even or both of them odd, because plus minus has no effect on parity, evenness. So both of them should be even because odd times odd will be odd. Again, contradiction. Here it is what? It is 2 squared times 14 squared. 14 squared is 2 times 2 times 7 times 7. So the first one is 2 times something, here 2 times something. Again, the difference, we know d is at most what? At most 30. Okay? At most 30. The numbers that we want to place here similarly should be at most, the difference at most 30. So for example, if you place 298, so it will be bad because the difference at most 30. If you place 428, 449, again it will be bad, the difference. 1414 not possible. The only possible case 728. Okay, so g minus d is 2 times 7, g plus d is 2 times 28. Now if we subtract 2d equals 2 times 28 minus 7. So if you divide by 2, d equals 28 minus 7, which is 21. Now g will be what? G is d plus 2 times 7, 14, which is 35. Okay. Now d 21, g 35. Okay. Now c will be what? C will be 9. And 9 squared plus 14 squared. 9 squared is 81. 14 squared is 196. 6 plus 1, 7. We have 1. 8 plus 9, 17. Plus 1, 18. 2. Let's check it again. Oh, sorry. Here, when it is 16, the next one is not 14 because it's not 30. It's 12. Okay, let's correct this part. It's 12 and, okay. For f12 squared plus 9 squared is 144 plus 81, which is 225. So f squared is 225, so f is 50. Now sum of them is what? 15 plus 35, 40, 50, plus 34, 84. So the answer is choice A. We have also similar problem from SMO, Singapore Mathematical Olympiad, and also AMC. AMC also. Let me tell you another homework from AMC that these things related to lots of similar triangles. Here, not similar triangles, lots of Pythagorean theorem and some problems of AMC, combination of Pythagorean theorems and similar triangles. If you want to know exact homeworks or what, feel free to send message to our WhatsApp number in the description. AMC 10A 2023. A rhombic dodecahedron is a convex polyhedron where each of the 12 faces is a rhombus and all of the faces are congruent to each other. The number of edges that meet at the vertex is either 3 or 4. So we have something like this, 3 or 4. And depending on the vertex, what is the number of vertices at which exactly 3 edges meet? So we consider this one T, this one F. The problem says T is what? Okay. Let's focus. It says how many vertices do we have? We don't have the okay, 12 faces and all of them. We can say T, sum of the degrees. One important idea is sum of the degrees equal to 2 times number of edges, because we calculate each edge twice from both sides. So the degree here, we have T vertices of this type plus 4F equals 2 times E. Now if I want to find number of edges in this polyhedron, you can say, okay, if we consider 12 times, we have 12 faces, each of them has 4 edges. If we draw like this, but when we calculate this, we calculate each edge twice, because each edge is in exactly 2 faces. So we divide by 2, so it's 48 over 224. Okay, now if you replace 3t plus 4f equals 2 times e, 48. Now we know 3 divides this one, 3 divides this one, so 3 divides f. 4 divides this one, 4 divides this one, so 4 divides 3t, so 4 divides t. By Euclid's lemma, because when 4 divides 3t, Euclid's lemma is what I said. Also, before exam, I said when A divides BC and GCD of A and B is 1, then we can conclude A divides C. Okay. So we can say F is 3F prime and T is 4T prime. So if you replace 3 times 4T prime plus 4 times 3F prime equals 48, we can divide both sides by 12, so T prime plus F prime equals what? Equals 4. Okay, so T prime can be what? T prime can be, in general, 0, 1, 2, 4. Okay, and we know T is what? T is multiple of 4. So if you check the choices, the only choice that is multiple of 4 is 8. Okay, so from up to this part, when we reach this part, we can find the choice, because we don't have any other choice that is multiple of 4. But let's try to calculate. We want to, for example, maybe we have this problem in USUM or USHAM or some full solution exam. We want to prove T cannot be 4, for example, or 12. We want to say T can only be 8. For this part, we should use Euler's formula. And we have also I remember other problem of AMC that we can solve with Euler's formula, and one problem of AME. Okay, I should search to see exact year was what. If you want to know, feel free to send message to my WhatsApp number. Okay. Now, it is what? Euler's formula, V number of vertices plus number of faces equals number of edges plus 2. V is what here? Do we know? We don't know. V. Face, we have 12 faces. E is what? E is 24. 24 plus 2. 26. So if you subtract 12 from both sides, V is what? V is 14. Now, we have V equals 14. And we know what? We know F plus T equals V. F plus T equals V, which is 14. And we know F is 3F prime, T is 4T prime. So 3F prime plus 4T prime equals 14. Okay, so if t prime be 0, 14 minus 0, it is not multiple of 3. If t prime is 1, so 4. If you subtract 4, 10 is not multiple of 3. If t prime is 2, then 8. 14 minus 8, f prime will be 2. Okay, 6 plus 8, 14. If it is 3, so this one works. 12 minus 14 minus 12, 2. 2 is not multiple of 3. And t prime cannot be 4 because f prime will be negative. So the only possible case is t prime equals 2. So t, which is 4t prime, equals 8. Okay, it is full solution. And the answer is D. Okay, if you want to solve related problems like these, two homeworks, or want to learn other ideas in graphs, Ramsey's theorem, and many other things, feel free in combinatorics and also other topics. Feel free to send message to our WhatsApp number in the description. AMC 10A 2023 problem 19. The line segment from A12 to B33 can be transformed to the line segment from this one A prime to B prime, sending A to A prime and B to B prime by a rotation centered at the point PST. What is S minus T? Okay, so let's draw this word. This one, this. Suppose, for example, this one. Let's write this one, for example, 4, 3. This one, and this one will be something like this. This word, this word, this word. A is what? 1, 2. Suppose it is origin. 1, 2. A is here. B is what? 3, 3. 1, 2, 3. A prime is what? 3, 1. 1, 2, 3. B, A prime. B prime is what? 4, 3. 1, 2, 3, 4. 1, 2, 3. And okay, so we have this rotation. We know what? We know when, for example, we have a rotation from, for example, P, A to A prime, we know that PA equals PA prime. It is, for example, rotated by angle alpha. So because PA equals PA prime, P lies on perpendicular bisector of AA prime. Okay, so similarly, so if we draw perpendicular bisector of AA prime, perpendicular bisector of BB prime, then the intersection will be P. So if we draw this perpendicular bisector and this perpendicular bisector, it will be some point like, for example, this one. Okay. Now this line is so much easy because BB prime here, it will be x equals 3.5. What about this one? If we want to find perpendicular bisector, we should find midpoint, 1 point, and then this slope and this slope are perpendicular to each other. We should find this slope, first this slope, then this slope, then equation of this line, and then find the intersection. Okay, these ideas. For idea 1, we should find midpoint. M is what? XA plus XA prime. It's 1 plus 3, 4 over 2, 2. And here 1.5. Now, idea 2, next idea, is that we know SAA prime. Suppose, for example, we call this line D times SD because they are perpendicular to each other. It's negative 1. S of AA prime is what? Is negative 1 over 2. So S of D is what? Is 2. The product should be negative 1. Okay, now, when we want to another idea, when we have a slope of a line and one point of the line is y minus y1 here, 1.5 equals S 2 times x minus x1, which is 2. So y minus 1.5 is 2x minus 4. So y equals 2x 1.5 minus 4 is minus 3 minus 2.5. Okay. Now, if we want to find intersection with this line, x equals what? 3.5. So if we replace y equals 2 times 3.5, which is 7 minus 2.5, is 4.5. Now the problem says PST team S minus the absolute value of the subtraction or the difference. 4.5 minus 1.5 is what is 1. So the answer is which choice? Choice A. Sorry, the answer is, I said 1. The answer is choice E. Okay, if you had question or want to learn more exactly before exam, one day before the exam, I release 3-4 videos. I said coordinate geometry. I said all these points: the slope, -1, the product, and these things. If you want to learn coordinate geometry or other topics, feel free to send message to my WhatsApp number in the description. AMC 10A 2023, problem 20. Each square is a 3x3 grid of squares is colored red, white, look R here, white, blue B, or green G, so that every 2x2 square contains one square of each color. One such coloring is shown on the right below. So here RGB white, here RGB white, and something like this. How many different colorings are possible? Okay, the idea here we want to use is casework, and also we should consider the most limited case. And I said these ideas the day before AMC 1012A 2023. Okay, if you saw my videos, you could solve this problem. Okay, so let's see how. Okay, let's paste the here. Okay. Okay, when we, for example, the most limited part, let's consider this one, we call it X, okay, one of the colors, it's not important. Then we have exactly one X. Now, for example, we have lots of choices, suppose it is Y, Z, we can, and this one W, okay, 4 different colors. This one and this one. If we consider this, or let's consider only this, these two things should be Y, Z. Okay, now we use casework. We say it is Y, Z or Z, Y. YZWX here, YZ or ZY. And then let's see what can we say in this part. Okay, in this part, in second part, we know this one. If you consider this one, ZX, YW. But if you have Y here, then here we have problems. So Y should be here, W should be here, and X, YW, Z should be here. In this part, because we have YW here, if you consider this part, it is YW or WY. So let's consider these two cases. YW or YWY. ZXZWY. Now, XZW here is Y, XZY here it will be W. Okay. So for each of them we can say X is which color, white or green, RGB. So for X we have 4 cases, for Y we have 3 cases. It is white or R or G or B. Okay, or white. Here again, when we use, for example, one of them for X, then we have 3 cases. Will be left for Y, for Z 2 cases, and for W 1 case. So it will be 24. For each of them, we have 24 cases. 3 times 24, it will be 72. Okay. So it was a casework problem. As I said before the exam, in all years of AMC, we have casework problems. We have problems that you should consider small examples and something like that. If you have question or want to learn more problems, want to work on more ideas, feel free to send message to our WhatsApp number in the description. Also, we have 2 homeworks for AMC 2020 in AMC 2022 that could be solved with casework problems. Also in SUMaC Stanford Math Tournament 2022, another homework we can say. Let me move it here, and also promise problems. These two are two prestigious summer camps. Okay, promise 2022. Okay. Let P of x be the unique polynomial of minimal degree with the following properties. P of x has a leading coefficient 1. 1 is a root of P of x minus 1. So it means that P of 1, if you replace x with 1, this one will be 0. So we can conclude P of 1 is 1. Next one. 2 is a root of this. So if you replace x with 2, it will be 0. So P of 0 is 0. This one. 3 is a root of this. So if we replace x with 0, P of 9 is 0. 4 is a root of this. So 4P of 4 is 0. So we can conclude P of 4 is 0. The roots of P of x are integers with one exception. The root that is not an integer can be written as m over n, where m and n are relatively prime positive integers. What is m plus? Okay. Because we know P of 1, 0, P of 0, 0, P of 9, 0, P of 4, 0, we have three roots. 0, 4, and 9. So x times x minus 4 times x minus 9. We have one exception. The root is m over n, so x minus m over n. Now, how can we find with m over n is what? By using this. P of 1 is 1. Because P of 1 is 1, we can say P of 1 is 1 times 1 minus 4, negative 3, negative 8, 1 minus m over n. P of 1 is 1 from first line here, from this one. Because leading coefficient is 1, we don't write any a here, okay? Leading coefficient is 1. Because, for example, if leading coefficient was 2, we should place 2 here. Now we can find m over n, because m and n are relatively prime. Negative 3 times negative 8, 24. So 24 times 1 minus m over n is 1. Now we divide both sides by 24, so 1 minus m over n is 1 over 24. Now we take these to right side, these to left side, so 1 minus 1 over 24 is m over n. Here it will be 24, 24 minus 1, 23. So because 23 and 24 are relatively prime, we can conclude m is 23, n is 24. The problem wants m plus n, which is 23 plus 24, which is 47. Okay, so the answer choice D. Okay, if you want to solve more problems related to polynomials in algebra, feel free to send message to our WhatsApp number. We have two homeworks. One of them AMC 2022, AMC A 12A, and one of them is AMC problem 2022, 12B and 10B, a common problem. If you are related to polynomials, and there are two important techniques. If you want to learn the two techniques or other things, other ideas, feel free to send message or WhatsApp number. AMC 10A 2023, problem 22, and AMC 12A 2023, problem 18. It says circles C1 and C2 each have radius 1. These two circles. And then it says what? Okay. And the distance between two centers is 1/2 this one. Circle C3 is the largest circle internally tangent to both C1, C2. Here. Circle C4 is internally tangent to both C1 and C2 here, and externally tangent to C3. What is the radius of C4? Okay. So before solving these, let me tell you 2 points. Okay, one important point is that let me see, it will be which idea? Idea 27, 28. Idea 28 is an obvious idea. If we have a center, if we connect this, it will be 90 degree. And why it is useful? Because when you have two circles that are internally tangent, then you can say, okay, the centers and the common points are collinear. Okay, O1, O2. Why? Because if we draw a tangent, common tangent here, if you draw from O1 to this one, it is perpendicular, O2 to this one perpendicular, two parallel lines, because they are perpendicular that have common point, then they lie on each other. Also, if you have two externally circles, then we have something like this. Let's try this one. Okay, suppose they are tangents like this. Again, by same idea, we can say O1 and O2 lie on each other. O1, O2, and this point, common points, are collinear. Okay. Now we want to use these points to find radius of C4. So at first, let's find radius of C1. We know what? We know O1 is here, O2 is here, and this point. By symmetry, we can consider that all points, all centers lie on this line, and O3 also lie here. Okay. Now we connect these 2 points, and we know what? We know this one is O3. Let me minimize O3, this point. Okay. At first, let's find radius of 3. R3 is what? Okay, R3, 2R3. Can we say it is what? Look, O1, this one is what? This one is 1 because of O1. And we know what? We know this part is R3. Okay, so this part is what? This part is 1 minus, or let's say we have this R3. We know this one is 1. Let me tell you in an easier way. Suppose here we can say it is 1/2, it is 1/4, 1/4 by symmetry. And we know this part is what? R3 minus 1/4. So this one is 1. 1 equals 1/4 plus 1/4, which is 1/2, plus R3 minus 1/4. So we can say what? 1 minus 1/2 plus 1/4. So it will be 3/4. R3 equals 3/4. Now we want to draw some lines. Here, if we connect O2 to this center, let's see what we have. Okay, so let me draw these circles. We know when we connect this one, O1 to O3, O2 for example, O3, I want to find this length. It will be what? This one is 1. This one is what? Here, O4. Is R4. Sorry. This one, let me erase this one. We know when you connect O4, it passes through this part, okay? So let me erase this one. It is O2, the whole part. Let me check. O2. And we have O4 here. Okay, let me consider this one. And we connect O2 to O4. Now let's see what happens. This length is 1. This length is R4. So this length is 1 minus R4. Okay? Because this is radius of 1. This one is radius R4. So O2, O4 is 1 minus R4. Now we know O2, O4 squared plus O4, O3 squared. O2, O4. If you use Pythagorean theorem, O2, O4 squared equals O2, O3 squared plus O3, O4 squared. Okay. O2, O4 is what? 1 minus R4 whole squared. O2O3 is what? Is 1/4. And O3O4 is what? Is R3 plus R4. R3 is what? 3/4 plus R4 whole squared. One equation, one variable. Pause the video and try to find R4 on your own. It will be 1 plus R4 squared minus 2R4 equals 1/16 plus 9/16 plus 2 times this 3/2R4 plus R4 squared. We can cancel R4 squared and then we can multiply. Let's simplify it. 1 minus 2R4. 1 plus 9, 10. 10/16 is 5/8. Plus 3/2R4. Now we multiply both sides by 8. 8 minus 16R4 equals 5 plus 4 times 3, 12R4. Now we take 5 to left hand side, this to right hand side. 8 minus 5, 3 equals 28R4. So if you divide R4 equals, if you divide by 28, 3/28. So the answer is choice D. Okay. If you had question or wanted to learn more things, feel free to send message to my WhatsApp number. And let me tell you also one homework. Homework. Here, the homework is what? You can consider this one and you can consider this common. You can consider this common tangent. Suppose O1, O2 is D. And try to find x, this common length of this common tangent, in terms of R1, R2. R1 is radius of this, R2 radius of this, and D. Okay, and this is helpful for these kinds of problems. You should consider common tangent. You should draw perpendiculars from centers and something like this. Okay, if you want to learn other ideas in geometry and other topics, feel free to send message to our WhatsApp number. AMC 10A 2023, problem 23. If the positive integer C has positive integer divisors A and B with C equals AB, then A and B are said to be complementary divisors of C. Suppose that n is a positive integer. It has one complementary pair of divisors that differ by 20 and another pair of complementary divisors that differ by 23. What is the sum of the digits of n? So we can write n as a times a plus 20 and b times b plus 23. Okay, and a and b are positive integers and also n is positive integer. So here we can say a squared plus 20a equals b squared plus 23b. Before the exam of AMC 20A or 10A 2023, I said an important idea. The idea was what? Is to write a sum of some squares, okay? Try to create some squares, sometimes equal to 0, sometimes in other form we can factorize. Here I can say it's a plus 10 squared, then I can create a squared and 20a minus 100, and this one will be b plus 23 over 2 squared minus 23 over 2 whole squared. This one will be the right hand side, this one left hand side. Now we can say a plus, then because we want to get rid of denominators, because we are working in integers, we multiply both sides by 4. So inside square it will be 2 to a plus 20 whole squared minus 400 equals 2b plus 23 whole squared minus 23 squared, which is 529. Now we take this one to left hand side, this one to right hand side. 529 minus 400 is 129. It will be 2b plus 23 whole squared minus 2a plus 20 whole squared. So it will be 129 will be sum of them, 2b plus 2a, 23 plus 20, 43. Subtraction is 2b minus 2a 23 minus 20 is plus 3. Now, if you prime factorize 1 to 9, it's 3 times 43. Now, because we know a and b are positive, this one positive, the product is positive, so this one has to be positive. So the only case, and this one is greater than this one because a is positive. So the only case is 1 to 9 and 1, or 43 and 3. For this one, if we subtract 2a minus 2a, 4a plus 43 minus 3 equals what? 43 minus 3, 40, which is not possible because a will be 0. So we should check this case. Again, this one minus this one will be 4a plus 40 equals 129 minus 1, 128. So we can conclude if we subtract 40 from both sides, 4a equals 88. So a equals 22. Okay. And now if we replace a with 22, 2b. Let's replace here. Minus 44 plus 3 is 1. So 2b minus 44 minus plus 3, 41. Equals 1. So if we add 41 to both sides, it will be 42. So b is 21. Okay, now if we check 2b minus 2a is 2, negative 2 minus 3, 1. Okay, and you can check also this one plus this one. 43, 2 times 43 will be 86, 126, and 129. Okay. A and B are these. And it says now sum of the digits of n is what? N is a times a plus 20. A times a plus 20 will be 22 times 42. If we multiply, it will be 84, 84. So it will be 4, 2, and 9. So 9, 2, 4. So the answer, which is sum of the digits, 9 plus 2 plus 4. So it's 11 plus 4, 15. So the answer is which choice? The answer is choice C. Okay, if you want to learn other ideas in number theory and algebra, for example, like this one, sum of the squares, feel free. And we have some, I know, some homework from BMO, British Mathematical Olympiad, and one problem from AMC. I should search to tell you exactly the years or what. If you want to know exact homeworks also, feel free to send a message to my WhatsApp number in the description. AMC 10A 2023, problem 24. 6 regular hexagonal blocks of side length 1. Here, 1 unit are arranged inside a regular hexagonal frame. Each block lies along an inside edge of the frame and is aligned with 2 other blocks, like this, 2 other blocks on this side, all of them. The distance from any corner of the frame to the nearest vertex of a block is 3/7 units. This one, all these things. What is the area of the region inside the frame not occupied by the blocks? Okay, so before the exam, I said properties, important properties of hexagon, regular hexagon, and regular octagon. Okay, hexagon and octagon. Here, hexagon useful. I said area, I said all, diameter, the day before the exam. I said all those properties. Now here, if you want to check, so we know, suppose this side length is a, we call this one a minus 1 minus this minus 10/7. Okay. Now this one is also a minus 10/7. This one is 1. Now if we consider, for example, this one, we know. At first, we have to find a. Why? Because the answer is what? Is 6. We know area of the larger regular hexagon is a squared root 3/4. I said this in my previous video before the exam, that the area of a regular hexagon is this, because it will be created by 6 regular triangle, equilateral triangle. For octagon also, I said the area is what? Minus. We have 6 regular hexagon, each of them 6 times 1 squared root 3 over 4. So the only thing that we should find is A. Now for finding A, we will use some important things. One of them is what? Because we have two ones that are parallel and equal, we know that they will create an equilateral, a parallelogram. Two opposite sides are equal and parallel. So these two lengths are equal. And we can call, for example, this one B, this one B. And this B, the first B is what? If you use cosine law, another thing before exam I said useful, cosine law. B squared is what? We know this angle is 120 degree. So B squared is 3 over 7 squared. In this triangle, we want to use cosine law, okay? So B squared is 3 over 7 squared plus A minus 10 over 7 squared minus 2 times 3 over 7 times A minus 10 over 7 times cosine 120. Cosine 120 is what? Negative cosine 60, which is negative 1 half. Okay. And if you want to use this B, if you want to solve this B, we can say, okay, we can draw this one because before the exam I said also length of all diagonals of regular hexagon. So when it is 1, if you draw this perpendicular, you will see, okay, it's 60. So this one will be what? Will be root 3. Okay, so. And now if we know this one, then we can find by Pythagorean theorem it is 90 because this one equals this one. It is 120 degrees, so 30, 30. So we call this one C. We can say B squared equals C squared plus root 3 squared by Pythagorean theorem. Now, here, let me maximize this part. I want to find a relationship again. If we draw this one, up to this part, it is what? This length? It is 1/2. Okay? And we can say what? We can say, if we consider this point and this point, let's see here, this length. It is what? You know, this one is 120 degree. It is 90. So this one is 60. Okay, so this one is 30. So this length is what? A. So because it is 30, this one is A half. Okay, this length. Now we can do the same thing for 3 over 7. If we draw this one is 1/2 of 3 over 7. I want to split this length into smaller cases. So if we draw this one, it will be what? Let me erase this one. Let me minimize. Okay, this length is what? 1/2 times 3 over 7. Why? Because this angle is 30. All of them are parallel to each other. And we can say this angle is 30 degrees. So this length is this. Now, this length is what? C. And this length is what? We said this one is 1/2. Okay, 30 degrees. And this length is what again? This part is 3 over 2, 3 over 7, 1/2 of 3 over 7. So sum of all of them will be A over 2. So A over 2 is what? Let's write 1 over 2 times 3 over 7, this part. This part is what? This part is C. This part is what? Is 1/2. And last part is what? 1/2 times 3 over 7. Okay, let's copy this part and use it here. Okay. Now let's simplify as much as we can. So this one will be what? A half equals. Let's multiply first. Because we want to find A, let's find C in terms of A. Okay. So A half minus 3 over 14. minus 1/2 minus 3/14 equals C. So C equals A/2 3/14, 3/14 minus 3/7 minus 1/2. So it will be A/2 minus 14, and it will be 6 plus 7. So it will be A/2 minus 13/14. So now we can do what? We say, okay, C squared plus root 3 squared, which is C squared plus 3. And this one equals this one. So C squared is what? Is this part. We can factor from 1/2 times A minus 13/7 whole squared. Also squared is for 1/2 plus 3 equals this one 9/49 plus A minus 10/7 whole squared. Negative 2, this one will be cancelled. Negative will be plus. It will be plus 3/7 times A minus 10/2 squared. 10/2 only this. Okay, so if we simplify, we can say 1/4. So let's write this one as this squared. 1/2 squared is 1/4. Now I want to get rid of denominators. So I multiply both sides by 7 times 49. So here 4 will be cancelled, and 49 inside squared will be 7. 7A minus 13 whole squared plus 3 times 4. Let's write it as 12 times 49. This one 49 will be cancelled. 4 times 9, 36. Plus 4 and 49 inside square, it will be 2 times 7, 14A minus 20 whole squared plus 4 times 3, 12, and 7 will be cancelled by 49, 7A minus 10. Okay. Now let's expand. So the first one is 49. A squared minus 7 times 13, 91. 2 times 91, 182A plus 169 plus 12 times 49 and equals 36. And here plus 196A minus 2 times 20, 40, 56A, 560A plus 400 minus 84A and plus 184A minus 120. Okay, now let's try to simplify as much as we can. Here it is A squared. So 49, 196, so 0 equals 51, 147A squared. And then for A, it will be what? All terms that contain A. So 84, 182. 182 plus 84 is 6, 16, 266. And then if we consider this one, it will be minus 260 will be 300. So 300, it will be 294 minus 294A. And if we consider constant terms, 120, this one 12, 169. Okay, so if we simplify, it will be, let me erase here. We have also 400. So 400 plus 36 is what? Is 436. Minus 120 is what? 316. Okay, so right hand side 316. If you take it to right hand side, it will be minus 169. 16 minus 9, 7. Then it will be 0, 10 minus 6, 4, 2, 147. Okay, so 147 minus 12 times 49. 12 times 50 is 600. 600 minus 12 is what? Is 588. So minus this plus this. So 588 minus 147 is 144. So minus, because 588 is negative. When you take it to right hand side, so it will be minus 441. Now let's try to divide both sides by 3 first. So it will be 49a squared minus 9, 24, 8a minus 3 is 114, 421. So now we divide both sides. So first by 3. In this part we divide both sides by 49. Will be a squared minus 2a minus 3. Now we want to find what? This part. So let's calculate a first. Here we can factorize a minus 3, a plus 1. Okay, so a is 3 or negative 1. Negative 1 not possible, so a is 3. Now we want to find this. A is 3, so 6, this one, 2, 3. So 3 over 2 times 3 squared, which is 9, 9 root 3. Minus 4, this 3, 3. Minus 9 root 3. So it will be what? If you factor from 9 root 3, it will be 3 over 2 minus 1, which is 1 half. So the answer will be 9 over 2, 9 root 3 over 2. Okay, so the answer is choice C. Okay, as I told you, I said important ideas of regular hexagon and octagon before the exam. If you want to learn other important properties in geometry that are useful in AMC, AME, SUMaC, and IMO, feel free to send message to my WhatsApp number in the description. AMC 10A 2023, last problem, problem 25, and 12A 2023, problem 21. It says if A and B are vertices of a polyhedron, define the distance DAB to be the minimum number of edges of the polyhedron one must traverse in order to connect A and B. For example, if AB is an edge, like what? Like this one. Then the distance is 1. For example, it says if AC and CB are edges like this, and AB is not an edge, distance is 2. 1, 2. For example, A here and here, the distance is 3. Okay, for this one and this one, for A and D. Okay, now we know the distance is the distance in graphs. Let Q, R, and S be randomly chosen distinct vertices of a regular icosahedron, regular polyhedron made up of 20 equilateral triangles. What is the probability that DQR is greater than DRS? Okay, as you can see, Q and S are symmetric with respect to R. So we know the number of cases that this one is greater than this is equal to the number of cases that less than this. So we can say, okay, we divide by 2, but we cannot divide by 2 because in some cases they are equal. So the only thing that we should pay attention to finding how many cases DQR equals DRS. Okay, without lots of generality, we can consider R is here. And if we want to consider cases, so it is first level. Let me call this one 1. The distance, these two, hang out from the vertex, this idea. So much important in graph. Hang out from a vertex, like this. Or we can consider this one as a root. And this one 3. So Q and R for this case can be from this part 1, 2, 3, 4, 5. 5 choose 2. Or we can say for Q we have 5 choose 2 times 2 or 5 times 4. For this one, for Q and S, Q, S. To be here in second level, I gave 5 times 4. Q and S 20, 20, 40. Now if we want to calculate the probability, we say, okay, how many cases do we have for Q and S? So 5 points, 1 point, 11. So 11 for Q, 10 for S. Then you subtract these cases, 40, you divide it by 2. Now it will be, because when you subtract these cases, the cases that are left are greater or less than. By symmetry, the number of cases that are greater equals number of cases that are less than, so we divide by 2 over number of all cases. 11 times 10 for Q and S. So, okay, let's simplify. Let's divide by 2. It will be 5. It will be 20. So 55 minus 20 will be 35 over 11 times 10. Now, okay, we can say 11 times 10. We cancel 5. It will be 2. It will be 7. So it will be what? It will be 7 over 22. Okay. So we have also some other ideas that are in graphs and important. And I can tell you many homeworks here. Homework 1, 2. Related to hangouts from a vertex. Related to AMC combination with Ramsey's theorem. And homework 2 with these probabilities that they have equal symmetry. Okay, if you want to know those homeworks or want to learn important ideas in combinatorics and probability, feel free to send message to my WhatsApp number in the descriptions. Okay, so we work on these problems. I told many ideas of this exam before the exam. And if you saw those videos, they were helpful. And if you want to learn more, as I said before, you can send message to my WhatsApp number.